All right, welcome everyone. We are in week 7, and today we're working on 207 and 2.08, which is dealing with cylinders. So hopefully you had a chance to print off the notes that I emailed to you. If not, and you're in person, I have copies for you. So as you're walking in, make sure you grab those. And we are going to jump right in today with a really fun estimation activity. So are we ready? I'm going to take you to a website, and it's called Estimation 180. It's a really cool website that is going to give you different scenarios and ask you to do an estimation. So before I go to this website, the website's going to be talking about volume. What is volume? Can somebody describe volume to me? You can either type it in the chat area if you're at home, or just think about it if you're here in person. What does volume mean? Anybody want to give it a whirl? Daniel? The amount of space inside something, or I like to think of it as how much liquid would fill up a space. You know, that's kind of thinking of volume. So what we're going to do is I'm going to show you a picture, and you are going to estimate the volume. Not by number. You'll see in just a moment. So let me go ahead and share this website. I want to share my whole desktop. Okay. And this is a site called Estimation 180. So I'm going to give you guys a moment, and it says order the glasses from least to greatest capacity. So they're labeled with the letter right now. On your paper, I want you to tell me, is it ABC, is it CBA, is it BCA? And then in one sentence, tell me why you think that's the case. And then I'm going to play a quick video for you. Okay, so the idea was, you know, you're going to pick the order of the 3, and in just one sentence explain why. Anybody pick B? If you're at home or in person, raise your hand. Anybody think B had the biggest volume? No one? One person? Okay. Well, let's find out. We're going to watch a video. And this video is going to be, well, it's really going to show us. So let's watch what he does here. There's no sound. I guess there's a little sound. So he took A and he poured A out. He took B and he poured it into A, and look what happened. B had less. Now he's dumping that one out, and he's going to check C. He is spilling. Yes, we'll talk about that in a moment. So A and C had the same, so he's lining those up together. So the correct answer would have been B first. B had the least, and then A and C were actually tied. And I know that's that's probably like a really hard thing to get correct on your paper. But let me go back to the picture right here, and let's think about that for a moment. Today what we're going to be learning is the formula for surface area and volume. This is a volume problem, correct? Because it's how much liquid fits inside of that cup. So we have to think, what parameters are changing the volume? Well, obviously the height plays a factor, right? Some are taller than others. But what would be the other key factor besides height? What's the other thing that's changing? The what? Sort of. We don't really call it length. What would we call it? The width. And the width would be like the top of the circle, and that has a special name, right? So all the way across the circle is called the diameter, and we're going to talk about radius today. Radius is halfway across. So kind of cool. Just starting today off with something a little bit different. Okay, so that's Estimation 180. I hope to pull in a couple more things like that each week just to get you thinking a little bit and about why you're picking the answer that you're picking. So what we're going to start with is our essential question. This part does not need to be copied down in anybody's notes because it's not the question. It says that it's going to be coming later in the session. You guys are going to be designing your own cylinder. today. So we're going to talk at the very end about a can of soda, and does a can of soda need to be the shape that it is to hold 12 ounces? So that's going to be the question that we're thinking about through today's session, and we'll be able to design a new kind of a can by the end of our session. Real life application. So where do our formulas come from? I really want to get you guys thinking about not just, hey, here I'm giving you the formula, but why is that our formula? So here is my question in red. What would the cylinder look like if we unrolled it and made it flat? Can you guys try and draw that for me? If I unrolled this cylinder and laid it flat, we used to call that a net last unit, right? Like when we unfolded all the pieces and laid it flat. What would this net look like? Can you guys draw it on your paper, please? And some of you are typing it in. If you're at home, that's awesome. Good job. So, you guys in the room, what do we think? If I unroll this middle section right here, what would it look like if it was flat? Yes. No. What shape would it be? It would be a rectangle. So if I unrolled the middle, it would be a really long rectangle where this is my height, and we'll talk about what we're going to label this in a minute. Plus, I would also have my top circle and my bottom circle. Is everybody okay with that shape? So here would be my net. I would have my top circle, my bottom circle, and a rectangle for this middle portion that's getting unrolled. Have you guys ever peeled the label off of a soup can and peeled it off? What shape is it? A rectangle. So a rectangle fits around our cylinders. What would this length be? Think about that for a minute. I'm unrolling this. What length is that? Think about it, think about it. What is this length going to be? It's something specific. Right? I'm unrolling, and we're talking about this would either be the top edge of your circle or the bottom edge of your circle, right, by the time you unroll it. So, hey, wait a minute, this isn't a random length. It's the distance around the edge of your circle. What do we call that? Close circumference. Good job. So let's label that. On your notes, everybody make sure you're writing this in there. That's actually your circumference. That's pretty cool. So we had a circular shape, we unfolded it, we made it a flat shape, but we know that that length is actually the circumference. Kind of cool. So how would I find the area of my unrolled shape? Well, I would have two circles. Everybody agree with that? Plus you have a rectangle. And what's your rectangle? The height times, we just said, the circumference. So we have a formula for circumference, right? 2 pi r. Good job. 2 pi r. Perfect job. So if I'm talking about surface area, what am I really talking about? You're talking about the two circles plus a rectangle. Isn't that cool? That's how you find the area. Just going to lay it flat, and then it makes a little more sense to us. Now we're going to move in and talk about volume for a minute. So again, where does surface area and volume come from? Now we're focusing on volume. So if I ask you how much water fits in this shape, think about it this way. Volume, here's your formula for volume. Area of the base times the height. The area of the base is a circle. Then I'm multiplying it times this height. Here's how I like to think of it. Really, it's like you're putting a whole bunch of circles in here over and over and over and over and over again. It's just circle after circle after circle after circle, and they're all touching each other. All of those circles make up the height, right? So you're doing this area times how many of these circles could fit in there. And that's how you find how much volume fits in there. Okay, just a new way to think about it maybe. Area of the top, and you're really doing the area of the top a whole bunch of times, the whole way down your shape. That's volume. So now let's go back to what are these formulas. The formulas look like this. So I give these to you on one of your sheets, and let's think about if these make sense. So volume is the area of the base, anytime you guys see big B always means area of the base. Do you guys agree? Whether we're talking about a square bottom, a rectangular bottom, the formula for B is going to change though based on what shape I give you. So if my base is a circle, I have to use the area of a circle, which is pi r squared. So make sure that you know for cylinder, yes, it's big B times h, but what's big B? Pi r squared. And then we'll fill our numbers in just a moment and try it on a new problem. Now for surface area, I usually like to say SA. So if you want to cross that off and just write SA. Sometimes in your book and in the online lesson they have this weird L. L means lateral area. So remember when we took our net and we said, oh yeah, that's a rectangle plus 2 circles? The L stands for your lateral area, meaning the rectangular portion. And sorry, this little star is a multiplication symbol. It should just be a dot. It just came out as a star. So sorry about that. You can fix that. Yep, should just be like a dot for multiply. So instead of saying L, I like to think of it this way. Height times the perimeter. Because remember what we did. We said that this was my height and this was my circumference. That's what we said on the last slide. Well, what is my circumference formula? My circumference formula is 2 pi r. So here would be your actual formula for surface area, which we knew. Why do we think it's 2 times the area of the base? Because I had 2 circles. I had a top, I had a bottom. You have 2 of them, right? Plus we're going to do the area of my rectangle, which is your height times 2 pi r. So we found this formula just by drawing the net. We were able to find that formula. So these formulas do make sense based on their shape and based on when we made their net. So now we're going to practice using them. Are we all okay with the idea that the perimeter is the circumference formula? Anybody have a question about that? So P means perimeter. The perimeter of a circle is the distance around the edge, which is the circumference formula. We okay with that? Okay. Now we're going to try some. So here's my first example. It says find the surface area and the volume. First thing I want you guys to do, if there's lots of lines on the notes that I gave you, can you guys please rewrite the surface area formula and rewrite the volume formula? Go ahead and start there. So rewrite the surface area formula, rewrite the volume formula. So next to surface area we should have h times p plus 2 times big B. Next to volume, it's big B times h. Okay, but we're not quite done yet. So I need to really fill in what P and B are. So I'm going to underline them. Please underline them with me. And what we're going to do is, instead of saying P, we're actually going to do the formula for how we find P. So H will stay H. P means perimeter, perimeter of the base. How do I find the perimeter of the base? What's my formula for perimeter? Who can tell me? Close. She said pi times radius. That's close. So I hear all kinds of things. So first, what is perimeter? Perimeter means distance around the edge. What's the distance around the edge? The circumference. So I need the circumference formula. Circumference formula is 2 pi r. 2 pi r. Okay, go ahead and write 2 pi r. See how I don't even have numbers yet? No numbers. I'm just doing the formulas. Now it's 2 times big B. Gary, do you remember what big B means? What about the base? Anybody help them? The area of the base. So anytime you guys see a big B, you're talking area of the base. A couple of you guys typed that in. Great job. So area of the base, well, look at my base. My base is a circle. What's the formula for area of a circle? Pi r squared. Okay, so I want you to flip your notes over. Everyone flip their notes over. I'm going to a new page here. We're going to stop for a second because you guys are missing some of your key formulas here. And we just need to write them down. That way we have them. So the two I want you to write down is area of a circle, which is pi r squared. And the other one you're going to need is circumference of the circle, which is 2 pi r. These you're going to need all the time when working with cylinders. Okay, so in my formulas, when I see a big B, you're going to use that formula. Right? Big B means area of the base. In my formula, when I see a capital P, that means perimeter of the base. I'm going to use this formula. Formula 1, Formula 2. Okay? A lot of it, I don't make you memorize formulas, right? I don't make you memorize them. You just have to know how to use them. So you guys can always have your notes handy when you guys are doing your quizzes, your tests, all of those things. You don't have to have these memorized. So it's okay if we don't know them, but you do need to know how to use them. So now let's go back. Now that I have all of my letters filled in, what we're going to do is right underneath that letter, we are going to fill in the number. So right underneath H, everyone look at your shape. Daniel Rodriguez, what do you think H will be in my picture? Yes. What number would it be? 8. Good job. Okay, next. I'm going to drop down my 2. I'm going to drop down my pi. What's my R in my picture? Tyler, what do you think? 6. Good job. So far, so good. Now I'm going to have 2. Drop down my pi. Now I need to do R squared. Thanks, Bethany. Adrian, in my picture, what's R? 6. 6 squared. So let me pause for just a minute. I want you guys to look over all of those numbers. Does anyone have a question about which one is H and which one is R? Everybody okay? So R, before I move on to my next example, this one's important. R is always part of my circle. We okay with that? R means radius of the circle, half of the circle. Height is always the number that's going in the opposite direction. Do you guys see how there's a difference? Your R is on your circle, your height's going in the opposite direction. We okay with that idea? Because I could take this and tip it on its side, and it would not change which one's R and which one's H. So I don't want you to think in your head, oh, H is always up and down. Nope. H is not always up and down. We have to identify it based on where your radius is. So radius goes one direction, your height goes the opposite direction. We okay with that idea? We need to finish solving this now. So look at the left side, and you're thinking, oh my gosh, that's a lot. It's not. It's not bad at all. They are all touching each other, which means what do I do with all of them? When things touch in math, what does that mean? It means, what do things mean when they touch? Multiplication. There we go. Perfect. So it just means multiply. I can multiply in any order I want to. So I could do the 2 and the 6 first and get 12. There's still that 8 out in front. Then I can do the 8 times 12. What's 8 times 12? I don't know. I did it a different way. 96? 96 pi. Let's try my right-hand side. Now, the right-hand portion over here, there is a correct order in which to do them because I have an exponent. You guys see that? I have to do order of operations, so I'm going to have to take care of that exponent first. So 6 squared would be 36. Good job. So now I have 2 times pi times 36. So let's do 2 times 36, which is going to give me 72 pi. So if I have 96 pi plus 72 pi.
Staff members, we wanted to let you know that Gold First is here in the conference room.
Sorry, hang on 1 second.
Your account. Also, they have a
Sorry, school announcement. Okay, so at this stage, what do I do? Do you guys have any idea? What do you think? I can add the 96 and the 72. I certainly can. Okay, so I can say 96 plus 72 equals 168 pi. So did you guys see what I just did right there? I didn't treat pi like a number. I treated pi like a what? Like, oh, not an exponent, close. Like a variable. You guys are right. Kind of cool. Treated it like a variable. I pretended like it was an x, and I just added them together. So let's think on a quiz. This might be your answer, saying inches squared. Or they might actually multiply out the 168 times pi. So on a quiz, if they're going to multiply it out, what is my approximation of pi? I do it times what? 3.14. So this could be your answer, or put a big fat or there. Or you could say 527.52 inches squared. You could have two different answer options. They are the same answer. Let me say that again. They are the same answer. They're just in different format. One has pi, one does not have pi. How is it going to be on a quiz? Probably both. We just have to make sure we can do both. We ready to try volume? Surface area is harder. Volume's a little easier. Okay, so I'm going to move my volume over a little bit because I am out of space. Let's shift this over. Okay, so flip your paper back over. Look at your notes. What did we say big B is going to be replaced with? What formula? Pi r squared. Fabulous. Let's fill in my numbers. So pi is going to stay pi. Destiny, in place of r, we'll put a, in place of r, what will we put? Is r2? So right here, so what we're doing is we're taking my formula and we're just replacing them with the numbers from my problem, from my picture. So what would r become from my picture? What's r in my picture? No, which one's r? What's r mean? R is the radius. Can somebody help her? Which number is the radius? 6. So all we're doing now, first step, okay, so let's backtrack a little bit. Step 1, write your formula. Step 2, replace any big letters with smaller versions of the formula. And then the last step is to put numbers in. So when I look at when I look at my picture, I need to replace r, I need to replace h. So looking at my picture, r would be 6. And from my picture, h would be 8. Aren't those the same numbers I used in surface area? Yeah. It's just a little bit of a different formula, but they're the same numbers. So out of all these things, I have to do my exponents first. So 6 squared, 36. And let's do 36 times 8. Good job. 288 pi. What kind of units go on volume? Inches cubed. Good job, Adrian. If you guys remember, last week I talked quite a bit about 2 dimensions and 3 dimensions. Area is flat. It's in 2 dimensions. That's why it says squared at the end. Volume is in 3D because volume is saying how much space does it take up. It's in 3 dimensions. So that's where those little exponents come from. Now, this could be your answer, or how else could they have it on a quiz? 288 times 3.14. So they could also say, let's put that big word or, 904.32 inches cubed. Same answer, different format. We're going to try again because first time's always sketchy, right? Second time gets a little more concrete. We understand it just a little bit better. So let's try one more time, and then we will talk about you guys redesigning a soda can to see what other dimensions could we make a soda can to hold the same amount of liquid. Oops. Okay. For our sake, we're going to stick to cylinders for today since that's our focus. But yes, obviously we could make many, many other designs to hold the same amount of liquid. So first things first, what did I have you guys do first in the last problem? You had to write out the formula. Please do that. So look back. It's okay to use your notes. You do not have to memorize them. You just have to know how to use them. So we'll say h times p plus 2 times b, but is that formula super helpful? Not yet, not until we change the p and the b. Flip your paper over. Remember how I had you write those formulas on the back of your paper when we first started today? So instead of p, we are going to say, what's perimeter again? Look on the back. Okay, you're not cheating, I promise. 2 pi r. Thanks, Gehrig. And how about big B? What will we replace big B with? Pi r squared. Fabulous. So now you guys have all your formulas in one place, right? On this paper right now. Don't give this paper to your homeroom teacher. Let me say that again. Don't give your original to your homeroom teacher. You can give them a copy. Everybody okay with that? You can give them a copy for your sample of work, but please don't give them this original. Keep it. Keep this paper. You want to use it. So let's fill in our numbers. You guys did great writing the formula. This one's a little tricky. What do you guys notice about the picture? It's different than the last one, right?
22 is the diameter.
Okay, that's a great observation. So one observation was 22 is the diameter. Nowhere in my formula do I need the diameter. That's right. Got to fix it. How do I fix it? Divide it by 2. Because if the whole way across is 22, can I easily find halfway across, right? Which would be the radius. So halfway across would be 11. That's your radius. So let's go right underneath the R, and we're going to put in 11. We did it a little out of order, but that's okay. It's not wrong. Which one would be H then? What do you think, Tyler? Which one's H?
9.
The H is 9, but that's weird. It's sideways. How'd you know that was the height?
Because it's part of the side and some part of the base.
Good.
The side is to kind of use the side is the part that doesn't have the base face has to have 2 equal shapes on each side.
Good job.
Doesn't need that.
So he had a great explanation. I just want to make sure you guys at home heard it. He said that the height is never part of the base. We knew that this one was the base because there are 2 similar shapes, right? There's the top, there's the bottom. So even though it's shifted on its side, it's still the height because it's not part of the base. That's a great way to explain it. Good job. Let's come over here and finish writing in the rest of my problem. I have plus 2 pi. Adrian, what's going to be R? 11 squared. Great job. Let's just work this out. And again, in any order we want is fine. So because it's all multiplied, so 2 times 11, I'll say 22. There's still that 9 out in front. So 9 times 22, 198 pi. Plus, let's do this side. This side does have a specific order I have to do it in though, because I have to do order of operations. So I have to do my 11 squared first, which is 121. And then I would say 2 times 121 would be 242. Now I can combine those two. We would get 440 pi feet squared. So I did have a question. Well, actually, nobody asked it, but I can think that you might think this on a test. Can't I multiply the pi out at any time, like say times 3.14 and over here times 3.14? The answer is yes, but what if this is the answer on the test? What if this is the answer on the quiz? It's easier just to keep pi in there until the very, very end and then see how they have their final answer on a multiple choice test. So if you have your phone, did you guys know that when you get your calculator out on your phone, if you tip your phone to the side, it turns into a scientific calculator? Kind of cool. It has logarithms and exponents and all kinds of crazy things. Kind of fun. You don't need it for this, but I just thought I'd throw that in there. So let's do 440 times pi. Are you allowed to use a calculator on your quiz and test right now? Yes, that would be fine with me. Because is a calculator going to do this whole problem for you? No. You have to obviously know what numbers you're plugging in where to get the right answer. The calculator won't give you the answer. So I am absolutely fine with using calculators. So 1381.6 feet squared. Any questions on that one? Didn't that feel easier than the last time? It's like, see? Only took you 2 examples to start feeling a little bit better with this stuff. I'm going to switch colors and we're going to try volume. Volume equals big B times H. Take a second. Can you fill in what big B really is? Look on the back of your page if you have to. So Teresa, what's big B? I know we've been all over the place in our notes today. It's area, which means, what's my formula? Pi r squared times h. So now let's fill in my numbers. So here we go. Pi stays pi. You guys have already identified them on the graph, right? So Tristan, what would r be? Perfect answer, 11. So I'm going to say 11 squared times my height, which we already identified as 9, right? So even though it's on the side, it can still be our height. That's fine. It's not a deal breaker. So I'm out of room. I'm going to do a little arrow. Forgive me. So that would be 11 squared, 121 pi times 9. So 9 times 121 gives us 1089 pi. What kind of units go on volume? You guys tell me. C cubed. Great answer. So they might have this answer, or they might do times 3.14. 3419.46. C cubed. So let me pause for a second. Do you have any questions about any of the steps that you see on the screen? So one question came through the chat area. So height is always perpendicular to the radius. Yes, that is absolutely right. Height and radius are always going to meet at a 90 degree. Good job. Yes. Any other questions? All right, so now here comes the fun part. Now we get to redesign a soda can. So before I show you your essential question, I haven't given you the essential question yet. It's coming right now. So here's a soda can. Forgive my drawing. I cannot draw to save my life. So there's our can of soda. How much fluid ounces is in a soda can? Do you guys know? Not 16, 12. So there's 12 ounces in a soda can. Now I looked online so that I could figure out, I wanted to know, I didn't have a soda can here with me at school today, so I wanted to know what was the height on our regular soda can, what's the radius on a soda can. If we're talking 12 ounces, are we talking volume or are we talking area? Think for a minute in your head. If it holds 12 ounces, are we talking volume or are we talking surface area? Can everybody type it in if you're at home? And everybody here in the room already said it. Say it a little louder. Volume. Talking volume. Okay, so volume, big B times H. I know you're thinking, I thought we were done with formulas. No, not just yet. Not just yet. Big B. What's big B? Pi. Pi r squared times h. So for a soda can, pi r squared times h equals how much? What's my volume? You just told me. You just told me. 12. So stop for a second and see if everybody's with me. We're talking about a soda can. We know that it holds 12 ounces. If we're talking about how much it holds, we're talking volume. So I wrote my volume formula. My volume is 12. We know that the formula is still big B times H, right? The area of the top times the height. Now I realize that a soda can cuts in a little bit at the top. We're not going to do all that. That's later. We're doing a very basic cylinder. Are we okay with that? So we don't have like the little lips and stuff going on, because that would be a crazier formula. Going to go basics. So I looked online and I found the radius and the height that would make this equal 12. So a traditional soda can you guys approximate for me, and I know I didn't even bring one in person, how high approximately do you think a regular soda can is? Kind of envision one in your head. How many inches off your desk do you think a soda can would be? About? 4, 5, 4 or 5? Is that kind of the consensus? Or we have a debate going on in here. It is actually 4.83 inches. So you guys were pretty darn close. 4.83 inches. Okay? And across the top, how far across the top do you think a soda can is? Let's estimate. Whoa, Anthony is really close. Say that louder. What did you say? He said 2.68 inches. It's actually 2.13 inches. You're close. That's close. That's close, I'd say, without having a sample in front of us. That's pretty close. So what that means is if I was to take my height and, oh, wait a minute, I don't really have my radius, do I? Okay, so for my formula, we're having a great discussion here. This is why I wish you were here in person with me. My height would be 4.83. My radius, not 2.13. We would have to have half of that, correct? So it'd be about 1.06, somewhere in there. So I'm just telling you, that's the height and the radius of a regular can of soda. You guys are going to come up with new dimensions for a soda can. So you are going to come up with a new height and a new radius. It's easier to think in terms of diameter and then divide it in half later. But I still want it to hold 12 ounces. So I work for Coca-Cola. Actually, I work for a Dr. Pepper company. It's my favorite, Dr. Pepper. So I work for Dr. Pepper, and I'm tired of my can being almost 5 inches high. I want it to be shorter, or I want it to be taller. So how do we think these numbers might change? If I made a taller soda can, how would this number change? If I made it taller, like let me do this. If I made it taller, it would get skinnier. Would you guys all agree with that idea? I haven't done any math yet. We're just thinking it through. If I made it taller, it gets skinnier. How about if I made it shorter? It get way fatter. I think both of them might be a little awkward to hold. We're not talking realistic here. That there's a reason that they picked these values for your soda can. It's really easy to grab a hold of and drink. Okay, so we're thinking of imaginary world right now. We're just trying to be designers and come up with something funky and new. So what I want you guys to do is you guys are going to design a new soda can. I want to know the height and the radius of your new can, but it has to equal, guess how much? 12. Still has to hold the same amount of soda because Dr. Pepper doesn't want to put 15 ounces in a can of soda. They still want to make it with 12 ounces. So think about this. Here's your essential question. We're not going to do 2. I was going to have you design 2, but I'm only going to have you design 1. So design a cylinder that would hold 12 ounces of liquid. Could be soda, Dr. Pepper, whatever you want to be. What possible dimensions could you use? So in the Dropbox for this week, we're doing like a real world problem right here, okay? A real world problem. And I want to know what would your radius be, what would your height be, so that your volume is 12. How many answers are there? A ton, right? Because if your height's 1.1, then your radius will be different. If your height's 5.6, then your radius is going to be different. There are a million different answers out there. So let's think about how we want to approach this problem. We are going to use our formula. So if I go back, you need this formula on your paper. Everybody give me a smiley face when that formula is on your paper. If you guys are here in person, you're going to work in teams on this for me. So you're just kind of lucked out today. You also need this formula on your paper. 12 equals pi r squared h. You guys are going to play around with the r and the h until you get it to equal how much? 12. Okay? You guys are going to find a value that you can use for r and h that are going to give me 12. You think it'd be a lot easier without pi? That's an interesting thing to say. In this example, I'll give you a hint. I would replace pi with 3.14. It's going to make it easier on you. Okay, so that's a hint to start with. And I'll give you one last hint before I let you guys go off on your way. If you guys pick your h to start with, then you would only have one variable left. So let me say that again. I'm going to clear some space for myself. If you pick one value to start with, then you're only going to have one variable to work with. So 12 equals pi r squared h. For instance, if I want my radius to be 1.5, that's an algebra problem. You're just going to solve for h. Do you guys see how you have all the other numbers there? That's easy. That's not hard. Okay, so I want you to play around with dimensions and give me a really good shape for your soda can. So I will hang out for just a second. Yeah, you're going to have lots of decimal answers. They should be decimal answers. You can round to 2 decimal places. Sound good? You don't need to put like 1.9587654 in the Dropbox. Just round it to like 2 decimal places. So you're going to give me the radius. You're going to give me the height for your shape, but the key is the volume must be 12. So have fun with this, and I look forward to seeing your answers in the Dropbox. Thanks, guys. Have a great day if you are at home.